Welcome to the review for the DCP number 2 that you're having. I did not pass this out to you. However, I sent you a blank copy in the Google Classroom a little earlier. Now I'm going to write a few notes to help you get this worksheet completed. Anyway, so let's get into it. Make sure you write your name on this. Haven't decided whether I'm taking this up or not. This really is something more for you to review. Just kind of to be familiar with what questions we might ask and how to do some of these things. Hopefully it'll refresh your memory a little bit. And let's get into it. So we are going back to quadratic equations. So you remember the standard form? Every quadratic equation is written in the form y equals ax squared plus bx plus c. Okay? Axis of symmetry. Every axis of symmetry, assuming that it's a vertical line, we're not going to talk about lines that go to the left and to the right. So x is going to equal negative b over 2a. So as long as you know the a and the b in your standard form, you can find the x coordinate of your vertex. The vertex form, on the other hand, y equals a, which is the same a from the standard form, parentheses x minus h squared plus k. And if you recall, hk is the vertex. How do you convert from standard form to vertical form? Well, that's kind of a tricky question. We really shouldn't answer it, but we're going to answer it anyway. How do you convert from standard form to vertex form? That's what we call completing. Oh, we can't read that. Completing. Oh, good grief. We complete the square. All right, let's see. Question number 1. Write an equation of the parabola that passes through the points -1, 4, 0, 1, and 2, 7. Okay, so we want a parabola, so we know this is a quadratic, not a linear. Best way to do this, use Desmos. I believe there's a table option where you can put in those 3 points that you know. And I believe that new option where you click those 3 dots or whatever, or the 3 lines, which will allow you to pick whether you want a linear equation, quadratic, cubic, or whatever other type of line you want. Or you can use the yellow calculator where you go into the stat edit and put in your points and then go under calc and look for the quad regression. And that should give you the equation of the line. So I'll just write in here Desmos or TI 84. That doesn't really look like TI. TI 84. And I'm going to put in parentheses stat edit. Okay? So if they give you some points, use one of those options. All right, so we're not going to find the equation of that line. Well, I guess we could come back and do that. So you should have come up with, just to make sure once you put in your data points, you should have come up with y equals 2x squared minus x plus 1. All right. Number 2. In 2011, the price of gold reached an all-time high. The table shows the prices in dollars per troy ounce of gold each year since 2006. T equals 0 represents 2006. Find a quadratic function. So they're telling us to find a quadratic that best models the data. Use the model to predict the price of gold in the year 2016. So they give us 6 data points. So again, either use Desmos or use the TI-84 doing the stat edit. Scroll up some. Using Desmos, you go in there and type in your points. They have the little drop down, that button with the 3 stars or dots, or the new button I told you about. And you should have come up with an equation. Y equals 28.17 x squared plus 45.65 x plus 617.5. Okay, that's your equation for every value of x when x is 0. So at year, what year is that? At year 0, which is 2006, the value should have been $603.46. So I must have typed something in wrong. Okay, so it looks like the formula is correct. So if we are looking for the price of gold at 2016, that would be 10 years later. So at 2016, y is going to equal $3,891 and some cents, but we rounded up to the nearest dollar. Very good. In the graph, which function has the same axis of symmetry as the graph of y equals x squared plus 2x plus 2? In this particular case, what is our axis of symmetry? If you recall, because that is a parabola opening up or down, x is going to equal negative b over 2a. So again, I need to know what a, b, and c are. So a is 1. So a equals 1, b equals 2, and c equals 2. Even though c is not in there, so it really doesn't matter. I am looking for which one of these x equals a negative 2 over 2 times 1. So that gives us axis of symmetry of x equals to negative 1. Which one of these has x equals to negative 1? Well, let's look and see. Expand this out just a little bit. So here, a is 2, b is 2. So negative 2 over 4, that's going to be a negative 1/2. I'm looking at, well, actually, let's write down what that should be. So I'm doing negative b over 2a. So here I've got a negative 2 over 2 times 2. That's not going to give me a negative 1. Over here I have a negative negative 6 over 2 times a negative 3. That gives me 6 over negative 6. That will give me a negative 1. And let's just check the others. I have a negative of negative 2 over 2 times 1. That negative and negative, that's going to be a positive, giving me axis of symmetry of x equals 1. It's not what I want. And then I have a negative 10 over 2 times a negative 5. So negative 10 over negative 10, those are both 1s. I'm looking for negative 1, so my answer should be B. Okay, yeah, I know I wrote all over there a little bit, but hopefully you followed along with me. I just found the axis of symmetry of my given equation, and then I checked to see which one of these had the exact same axis of symmetry, which was x equals negative 1. All right, which function represents the parabola with the widest graph? Explain your reasoning. So for the widest graph, we need to know a couple of things. First of all, we know that if a is larger than 1, the graph stretches. These are vertically stretches. Graph stretches. If a is between 0 and 1, the graph compresses or shrinks. So when a is greater than 1 and my graph is stretching, my graph gets narrow. When a is between 0 and 1, my graph compresses, so the graph gets wider. My graph gets wider. So I'm looking to see where my a value is between 0 and 1. The closer we are to 1, the wider our graph is. The further we are away from 1, the less wide it is. So let's look at our answers. These are already written in vertex form. So let's do this in blue. I'm looking at 2. My vertical stretch or shrink is 2. My vertical shrink or stretch is a 1 here. It's a 1/2 there and a negative 1 here. So which one of those falls between 0 and 1? It should be option C. So it doesn't really matter because all the other ones are stretches, so they get more narrow. The only one between 0 and 1 is at 0.5, and that's where we get wider. So that is the widest graph. To the next page. Find the difference. Now we're dealing with the complex numbers. So difference means subtraction. So subtraction. So we are looking at 9 plus 5. Nine plus 5i minus 11 plus 2i. All right. We are not going to have enough room, so let's go create another page. We'll rewrite that. Negative 2 plus 3i. Now I'm going to erase this. All right, so let's see what we got now. Find the product. 7 plus 5i and 8 minus 6i. We'll go back to our equation. 86 minus 2i. I. Do not combine the real number and the imaginary number. Please do not do that. Okay, solve the quadratic equation by factoring or using square roots. What do we have here? Remember, before we can solve any of these things, before we can factor, do any of this, we need to set this equation equal to 0 unless we are doing the perfect square thing where we take square roots. Okay, so we only have x squared, so no x's, so we could bring everything over to one side and take a square root. Let's see what we get. All right, so we should have enough room to do this. So we have 3x squared. I'm going to add 4 to both sides, so that should equal to 15. Okay, let's just put up here plus 4 plus 4. Okay, I'm isolating x squared, so I'm going to divide each side by 3, and I find that x squared equals to 5. When I take the square root, I find that x equals positive or negative square root of 5, because there are no perfect squares there. Okay, let me circle that. Well, I'm going to draw a box around it, not circle. Okay, so now going back, now we have x squared plus 6x minus 16. Very good. We're going to do quadratic formula. Well, actually, it tells us to use square roots. Why would we use square roots? It's interesting. Oh, factoring or using square roots. Okay. We could do the quadratic formula if we wanted to. This seems like a lot of work. So let me separate this over here. So if I draw my x bar, my a and my c, so I know a equals to 1, b equals to 6, c equals to negative 16. So when I come over here, I'm going to have a negative 16. Factors that multiply to negative 16 add up to a positive 6. So when we write all of our factors of 16, we have 1, 16, 2, and 8, 4, and 4. Okay? That's a negative. So I know I have a positive and a negative multiplying. And because the 6 is positive, I know my biggest number or biggest factor should be plus. So I'm going to put a negative sign on these. When I add these up, which ones add up to 6? That would have to be negative 2 plus 8. So I could come over here and have negative 2 and plus 8. Put an x in front, and I got my factors. So I have the factors x minus 2 times x plus 8 equals 0. Because that's equal to 0, I set each factor to 0. X minus 2 equals 0. X plus 8 equals 0. And I find that x equals 2. X equals negative 8. I'm going to circle that. Well, I'm not circling. I'm going to put a box around it. And we're good. All right, so we did one factor by taking the square root. We did other factor by the other quadratic equation by factoring. Write the equation in vertex form and identify the vertex. Okay, so since we don't know the vertex and we've not learned how to complete the square, we have to do what we do know. I know from standard equation, let's just write a equals coefficient of x squared, which is 1. B equals negative 2. C equals 20. I don't really need to know anything about C because I'm going to use the formula for axis of symmetry, which is also the x coordinate of my vertex, is negative b over 2a. So if b is a negative 2, I have negative of a negative 2. Please do not confuse the negative of our equation with the negative on the value of b. That is a negative of the negative b. Over 2 times a is 1. So that gives me 2 over 2. So my x coordinate of the vertex is 1. If x is 1, go back to your equation to find what y is. we know that y equals x squared. So 1 squared minus 2 times 1 plus 20. So 1 minus 2 plus 20. And that gives me, what, 19? My vertex is 119. So I'm going to, for my vertex form, y equals a is the value here. It's 1, so I don't need anything. X minus 1, all of that squared, plus k, which is 19. All right, hopefully you can see that. All right. Oh, we're almost done here. So now you are playing a game of horseshoes. One of your tosses is modeled in the diagram, over here, or this picture here. Okay, where, let's just highlight the important stuff. X is a horseshoe's horizontal position. So going from left to right, that's what X is. That's in feet. And Y is a corresponding height in feet. So Y is going up and down, X is going across. Very good. Find the maximum height of the horseshoe. Then find the distance the horseshoe travels. So, in other words, we are finding, if I find the vertex, I can first of all find my height, because that's going to be the Y value. Remember, the vertex is the maximum or the minimum point. So just a side note, find vertex. Then I'm going to find my x-intercepts, because where I'm throwing it, my x value is 0. So I just want to know the distance, not from where it left the ground to where it hits the ground, but from where this young lady threw it, which when x is 0, to where it lands, which is my x-intercept. All right, so what do we have? They gave us the equation. So here I know, actually, let me erase all of that. So I know that A equals negative 0.01, and I know that B equals 0.3. And I don't necessarily need C, but that would be 2. I'm not going to put that in there because I don't need it to find my vertex. All right, so what is X? X equals, as we said above, negative B over 2A. So that's going to be a negative 0.3 over 2 times a negative 0.01. Okay, so when I calculate all that out, that's going to give me a wonderful negative 0.3 over a negative 0.02, which turns out to be 15. Okay? Now, hopefully you found that to be 15. All right, so my x-coordinate of my vertex is 15. So now I need to substitute back into this wonderful equation. Put that in there. Use your calculator. Don't try to do this in your head. The maximum height turns out to be about 4.7. Okay, let me delete some of this stuff so it'll look neater. And the distance a horseshoe travels. So now, if I I know my vertex. So now, if I find my x-intercept, what is the value of x? That's the distance that the horseshoe traveled. So I need to set my y value to 0, okay? Because when I hit the ground, y is 0. So take your equation, put x in for 15, or put 15 in for x, and whatever that gives us, we will find that the distance a horseshoe travels is about 35.62 feet. All right, let's see. Nine plus 5i minus 11 plus 2i. So once again, we need to distribute that minus sign throughout the second parentheses. Because remember, subtraction is just adding the inverse. So that's really 9 plus 5i minus 11 minus 2i. And notice the minus sign went through the 11 and the 2i. So now combine your like terms. Never mix real numbers with imaginary numbers. 9 minus 11, that gives me a negative 2. 9 minus 11. And 5i minus 2i gives me a plus 3i. I want this in a form of a plus bi. I've already got in a plus bi. So let's go back, negative 2 plus 3i. Other screen, erase this. So we can do FOIL or box method. I forget which one you like, but either way. 7 plus 5i times 8 minus 6i. Okay, whether you do the box method or the FOIL, you're still, actually, we're going to do something different. We're going to multiply this 7 by everything in this second parentheses, and then the 5i multiplying by everything in the second. So now we have 7 times 8. So we could say those are our first terms, plus, if we do the outside, we have 7 times a negative 6i. Those are the outside terms. Plus, we have 5i times 8. Those are inside terms. Plus a 5i times a negative 6i. Okay, those are 4 terms that we are multiplying. 7 times 8 is 56. 7 times a negative 6i is a negative 42i. 5i times 8 is a positive 40i. And 5i times negative 6i is a negative 30i squared. So everywhere where we see I squared, we know that equals to negative 1. Okay, do not forget that. So I'm going to replace I squared with a negative 1. So putting in all of my steps, 56 minus 42i plus 40i minus 30 times a negative 1. That's going to become a positive 30. I'm going to combine my two imaginary numbers. I have 56 minus 2i plus 30. Add the 56 and the 30. That gives me 86 minus 2i. 86 minus 2i. Come back to my, go to our next page. I'm going to go ahead and erase that just in case I need it. My last question. All right. I know you haven't seen this before. Well, you've seen graphs opening up and down, but not opening left to the right. So quick explanation, and that will actually help us with our process of elimination. Now, you don't have to work all these problems if there's an easier way to do this. Okay, so real quick, my graph opens right or left. Okay, we actually are pretty familiar with the graphs that open up or down. And those are in the form of y equals a x squared. Okay? Graphs that open left or right, we need to switch those around because those are going to be the opposite. X is going to equal a times y squared. Okay? A is just whether we have a vertical stretch or shrink. Okay? So let's look at our graphs. We have y equals 1/8 x to the y. X squared. Okay? I know that graph opens up or down because it's y equals x squared. So I can actually eliminate that because my graph's opening left or right. X equals 1/8 y squared. Okay? That's opening left or right. So we're going to leave that. We're not worried about the direction yet. I can also, because here's another y equals x squared, I can eliminate that. Because remember, y equals x squared, that's opening up or opening down. Now, let's take a look and see. If I open to the right, I'm going to have a positive a value. If I open to the left, I'm going to have a negative a value. Which way is my graph opening? It's opening upwards. Not upwards, opening to the right. So I need to have a positive a value. This right here actually is my answer. And because that's opening to the left, I can eliminate D as well. Okay, so let me erase the bad answers. But that's how I eliminated 3 of my 4 answers and picked my correct answer. All right, I hope that helps some. And good luck on your DCP tests. Any questions that you have, bring to class, and we can answer those before the class starts. All right, good luck to you, and have fun.